next keynote profile, Kumar Ratra, independent researcher, innovative e-commerce system architect, and technology leader in retail technology USA. His expertise includes scalable distributed systems and event-driven architecture, high-throughput platform engineering for large-scale retail systems, e-commerce technology, and expertise platform development. His today's topic is engineering innovation at planetary scale, designing high-throughput event-driven systems for the digital economy. With that, let's warmly welcome Karan Kumar Ratra.
Hey everyone, let me share my screen. Are you able to see? Oh, sorry, I shared the wrong screen. Are you able to see my screen?
Yes, sir.
Let me share. Okay. First of all, good evening, good afternoon, and good morning, everyone in the meeting. Thank you, and thank you, organizers, for organizing this such a wonderful event for ICAESET 2026 and inviting me to present. My name is Karan Kumar Ratra, and I work as a senior engineering leader in Walmart. I focus on designing large-scale distributed systems for global e-commerce platforms. Today, I'll talk about designing the high-throughput event-driven architectures for e-commerce fulfillment at a global scale. So, modern digital commerce operate under extreme conditions, and as we have seen post-COVID, millions of transactions and real-time inventory updates, global logistic coordinations, and unpredictable traffic spikes occurs during such seasons, like flash sales or holiday seasons. And these traditional architectures are struggling to keep up with these such random demands. In this talk, I'll focus on why the event-driven architectures are becoming the backbone of any modern e-commerce systems and how they technically work, and what patterns enables them to scale globally. Let me go to the second slide. Okay. The first question that comes into my mind is like, what are these monolithic systems and why do they fall short? This slide will highlight the limitation of the systems in any global e-commerce environments. To understand why these architectures must evolve, we must first need to understand the limitations of any traditional monolithic systems. Monolithic architectures typically bundles everything, including your application logic, any order processing systems, payment gateways, inventories, shippings, into a single deployable unit. While this will work for any small systems or any small organizations, it becomes really problematic as the system grows or as the traffic grows in that website or in that system. The first problem in that monolithic systems will come with the performance bottlenecks, which means in these monolithic systems, the services communicate synchronously and every component waits for any other component to finish before continuing, which means there is a chaining behavior which blocks or slows down the entire system. The second issue in this multi-systems comes is the domain inconsistencies. When multiple modules are sharing the same database and same data models, small changes in one module can affect the other module, which means there is a domain consistency. And the third limitation that comes is a slow feature delivery, which means if you have to deploy anything or new feature in the system, it becomes really slow to deliver those features in the production because we have a lot of things to take care of. Everything is complicated to make any change in the big monolithic systems. And in large e-commerce platforms where the availability and speed are critical, these limitations will become really unacceptable. That's why the organizations are increasingly moving towards the event-driven architectures, which allows the services which are the independent services, to operate independently while still collaborating through the events. And that is a need why any monolithic systems should move into these ED architectures. Go to the next slide. Okay. Which brings to the question, what is EDA? EDA stands for Event-Driven Architecture, but it is a design pattern where the system components communicate through the events rather than direct synchronous calls. What is an event? Event is a represent event is an basically it is considered as a state in the system. For example, when a customer places an order, the action generates an event called as order placed. And in an event-driven system, the services generating the event is called the producer. The event is then sent to an event broker, such as Apache Kafka or cloud or any cloud services like Google PubSub, which is called the event broker. And the party consuming those messages, those events, are called the consumers, which are subscribing to the events they care about. Just to give an example, an order service produces an event when an order is placed. The inventory services will consume the event to update their stock levels. The payment services will consume the event to initiate a payment authorizations. Likewise, the shipping services consumes it to prepare delivery. So these are the events on which those services will interact and perform their workflow. One powerful concept here is called the event carried state transfer. So instead of asking other services through the data and by making an API call, the event itself contains all the necessary information for them to trigger their workflow and start an action. This eliminates any extra networking calls and reduces the latency significantly, which means event-driven architectures will do the same way, but with it in modular fashion, and will also be able to scale independently. Let's come to the performance. What does the event-driven architecture gives us by the performance? They are the high throughput by design, which means one of the most important benefits of event-driven architecture is the ability to support extremely high throughput. In modern e-commerce or any event streaming platforms like Apache Kafka, these can process hundreds of megabytes of messages while maintaining the same latency or even low latency. And there are several reasons for this performance. The first reason for this high throughput performance is the asynchronous communication, which means in this case, the producers publish the events without waiting for the downstreams to respond. This prevents blocking and improves overall responsiveness. The second most important reason is the parallel processing, which means these event streams are divided into partitions, and each of these multiple consumers can process their own partitions simultaneously. They don't have to wait for other partitions or consumers to complete and then kickstart their partitioning processing, which means there is no chaining process here. Every system can process their events in parallel. Third most important reason for this high throughput design is a zero copy or input. In this case, the technologies like Kafka can move data directly from the storage to the network buffers without passing through unnecessary CPU operations. So there's no processing involved. They're just passing the data, and the other system which requires the data can process whenever they require. Together, these design principles allow event-driven architectures to process millions of events per second, which is very much essential for any global e-commerce systems. Now, how do these event-driven architectures comes into the fulfillment lifecycle? Event-driven architectures becomes particularly powerful when applied to the entire fulfillment cycle, not in a part of the fulfillment lifecycle. When I say the entire fulfillment lifecycle, starting from your order creation to payments authorizations to fraud checks to purchase order creations to sending to the fulfillment centers to making it till the customer delivery address. So if you apply this event-driven architectures end to end, it really will solve the entire fulfillment lifecycle for any e-commerce systems. Now, let's consider a simple scenario where a customer places an order, and instead of single service coordinating every step sequentially, the order generated an event called order placed. This event triggers multiple processes simultaneously. Inventory systems will update their stock availability, the payment services begins authorizations, warehouse systems prepares for order packing, and the logistics system starts calculating the delivery options. Because all of these services react independently with the same event, the system is able to process them in parallel rather than in sequential. This approach dramatically reduces the response times and improves their scalability. For example, the event-driven inventory systems can detect stock changes in less than a second, significantly reducing the overselling scenarios. Similarly, shipping systems can automatically generate labels and coordinate carriers through event notifications. This distributed event flow allows the entire fulfillment ecosystems to operate efficiently at scale. Now, let's come into the business impact. Once introduced, once the introduction of event-driven architectures comes into the play for any e-commerce or any e-commerce platform, you can see the impact of this drastically. Which means when organizations transitions from the traditional event-driven systems, the benefits really becomes measurable. As you can see in the slide, first one is the latency. The latency reductions can exceed 70% compared to the traditional request response architectures. In the second, you can see the development teams gain faster time to market because services are decoupled, teams can deploy the features independently without coordinating with the large system releases. You can also see the infrastructure efficiency is improved. Event systems eliminate constant pulling between services and instead of delivering the information only when something is changed. This push-based communication reduces the network traffic and infrastructure costs, which means you can save in the costs as well. Another important improvement is the reliability. With better fault isolations, the system's uptime can increase significantly, which means the system is always available and you can get more nines about your system's availability. Even the small improvements in the responsiveness can have a direct impact on business outcomes, including the higher conversion rates, better inventory accuracy, and improved customer satisfaction. Go to the next slide. Now, real-world case studies. As you can see, these architecture patterns are already powering many of the world's largest digital commerce. For example, Target uses Apache Kafka to stream events in one store point of sale systems and online retail platforms. This enables real-time inventory synchronizations like buy online, pick up in stores, and Shopify also uses the webhooks. Meanwhile, the Confluent, the commercial platform built around Kafka, enables organizations to handle billions of events daily while maintaining sub-second process times. These implementations demonstrate the event-driven architectures has moved beyond just a theory. It is now a proven enterprise scale solutions for any modern e-commerce platforms. What are the advanced architecture patterns for any event-driven architectures? These are basically the Saga patterns, event sourcing, CQRS, and event mesh. To build any large-scale event-driven systems, several advanced architecture patterns are commonly used. Let me briefly explain the four most important ones. The first one is the Saga pattern. This is used to manage distributed transactions across multiple devices. Now, in the traditional databases, a single transaction ensures consistency using ACID properties. However, in distributed microservices systems, a single transaction may span multiple independent services, which means the Saga pattern breaks the large transactions into a smaller sequence of steps. Each step publishes an event that triggers the next steps. If inventory fails after the payment succeeds, the compensating transactions is triggered, such as automatically issuing a refund. Let me give an example of the saga pattern. For example, in any e-commerce order workflow, you have an order services creates an order, then you have a payment services processing the payment, then you have inventory which reserves the stock, and finally you have a shipping services which will schedule the delivery and ship your order. In this case, let's say the step 2 fails, which is the step 3 fails where you have the inventory reservation. The compensating transaction is basically to re- uh, revert your amount charged back to your account, which means back to your credit card or the savings account. This allows distributed systems to maintain consistency without centralization transaction loss. The second pattern is called event sourcing. In this, the traditional system stores the current state of data, which means an order might simply show status as shipped, but instead of storing the final state, the system also stores what has happened previously, which means it will also state your previous flow of the system, which is order created or payment authorized or inventory reserved, and the current state, which is order shipped. This is powerful capability wherever we have to have audit trails, we have to have historical states, or rebuilding any system states after failures. Third pattern is called the CQRS, which is Command Query Responsibility Segregation. CQRS separates write operations from read operations, which means commands modify the systems while queries retrieve the information. In any high e-commerce systems, reads are often far outnumbered than the writes. For example, thousands of customers may view the same product, while only few will place the orders. And the CQRS allows the systems to maintain a separate models, which is optimized for each workload, which means you have read in a separate workflow load and write in a separate workload. Write models ensures the consistency, while the read models can be replicated and optimized for fast queries. The fourth and last, which we are going to touch upon today, is the event mesh model or event mesh infrastructure, which means the event mesh enables global event routing across distributed infrastructures. Which means instead of relying on a single centralized broker, event mesh connects multiple brokers across clouds and regions. Let's take an example. Like, an order event generated in North America can automatically propagate fulfillment systems in Europe or Asia. So this architecture reduces latency, improves reliability, and ensures events reach the correct systems regardless of the geographic location. Now, together, all of these four patterns provide the architectural foundation for any globally scalable event-driven platforms, and which is right now the case for any e-commerce platforms. They want to go global, not local. Now, let's check upon some of the challenges while implementing this event-driven architectures in any e-commerce platforms. While the event-driven systems offer significant benefits, they also introduces some of the challenges. One most important challenge is the schema evolution. As the event structures changes over time, teams must ensure the backward compatible technologies like schema registries can help manage event vision safely. Another challenge that comes is the distributed tracing. Because the events are flowing between different systems asynchronously, the engineers must track the request using correlation IDs that propagates through the event to make the troubleshooting or issue triaging easier. Data consistency is another concern, and event-driven architectures systems typically rely on eventual consistencies, which require careful design using patterns such as the saga pattern. Operational reliability is also another mechanism where this could be a challenge to implement event-driven architectures and e-systems. And operational reliability means idempotent consumers, dead letter queues, circuit breakers for cascading failures. Together, these best practices ensures that pipeline remains stable and resilient even at massive scale. Which brings me to the final conclusion slide about the future directions and conclusion. In conclusion, the event-driven architectures has become a strategic foundation for any modern digital commerce platforms. By decoupling services, enabling asynchronous communications, and supporting massive event throughput, these systems provide horizontal scalability, fault tolerance, and real-time responsiveness. Looking ahead, we are likely to see new innovations such as adaptive event routing, where events are dynamically routed based on the system load or geographic locations. We will also see federated observability, which means it will enable engineers to trace transactions across multiple cloud environments. And perhaps the most exciting is the integration of AI-driven event systems, where machine learning models optimize event processing, retries, and real-time personalizations. Ultimately, the event-driven architecture is not just a technical pattern, it is becoming the operating model for any global digital platforms. Again, thank you very much for your time, and I would wait for any questions that you might have.
Thank you so much for that insightful presentation, sir. If any participant has any question, they can raise their hand. So, as there are no question at this moment, thank you so much, sir, once again. Thank you.
Thank you.